we discussed about the gyroscopic effect on aeroplanes. Now we will start the gyroscopic effect on the novel ship. So first, what are the general terms we will use it in novel ship, and what are different cases available? That means what are the gyroscopic couple available in different cases in novel ship. So first we will see what are different terms used in novel ship. So here this is the novel ship. So here we have four axes. So this is the longitudinal axis, this is the axis of spin, and this is the transverse axis, and this is the axis of spin. So the axis of spin is nothing but rotation of the axis is called axis of spin. Okay, so mainly we have three axes: longitudinal axis, transverse axis, axis of spin. And next one is axis of spin is nothing but rotation of the axis is called axis of spin. So here the rotation of the axis is called axis of spin. So first, here longitudinal axis is horizontal axis. So always longitudinal axis and transverse axis is perpendicular to each other. Okay, so the axis which is perpendicular to the longitudinal axis is called transverse axis. Next one is axis of precision and axis of spin. So always axis of spin and axis of precision is perpendicular to each other. So when there is a relation between axis of spin and axis of precision is perpendicular to each other, then only we have gyroscopic couple. So when the axis of spin and axis of precision is parallel to each other, there is no gyroscopic effect. So okay, you have to remember this point. When there is a perpendicular position of axis of spin and axis of precision, then only we have gyroscopic couple. When the axis of spin and axis of precision is parallel to each other, there is no gyroscopic effect. Always you have to remember this point. Okay, next, what are the terms we will use here? So this is the front end of the ship, so that is called bow. Front end of the ship is called bow. Rear end of the ship is called stern. Okay, next, this is called port and this is called starboard. Port and starboard we will see in the these terms, port and starboard, we will see in the second topic, that is pitching. So first we have to see what are the terms we have to use in the novel ship. Okay, these are the different terms we have to use in the novel ship. Rotor means it is rotates in clockwise direction or anti-clockwise direction. So this is active gyroscopic couple, reactive gyroscopic couple. So here the gyroscopic effect of the novel ship during steering, left turn or right turn, it is similar to that of aeroplane. Okay, so here first, what are different cases available in novel ship during that means in gyroscopic effect. Okay, gyroscopic effect in novel ship in three cases, mainly steering, pitching and rolling. Okay, so these terms are gyroscopic couple on novel ship. The effect of gyroscopic couple on novel ship, we have three cases. First one steering, and second one is pitching, third one is rolling. Okay, first we have to see effect of gyroscopic couple on novel ship during steering. So first we have to know what is steering. So steering is nothing but turning a complete ship in a curve towards left or right. So when ship or any vehicle, ship or aeroplane or four-wheeler, anyone when takes curved path means it takes left turn or right turn. So when it takes left turn, it has again two cases: active gyroscopic couple, reactive gyroscopic couple. Active gyroscopic couple means anti-clockwise direction. Active gyroscopic couple means clockwise direction. Reactive gyroscopic couple means anti-clockwise direction. Okay, so here first, steering is the turning of a complete ship in a curve towards left turn or right turn while it moves forward. So here consider a ship taking left turn. So when the ship takes left turn and the rotor rotates in the clockwise direction, okay, and viewed from the stern. So generally when consider steering, okay, in steering case we have the observer is at the rear end, so rear end is called stern and front end is called bow. So always the observer is at the rear end. Okay, next when the ship is takes left turn and the direction is clockwise direction, so we will see what is the effect on this position. Okay, so this is the novel ship when takes left turn. So this is the left turn position. Okay, this is the left turn position. This is active gyroscopic couple, reactive gyroscopic couple. Okay, all these terms we know. Next, so this is the effect of gyroscopic couple on a novel ship. Okay, so first when the rotor of the ship rotates in clockwise direction when viewed from stern, that means rear end of the ship, it will have its angular momentum vector in the direction of OX. So here initially angular momentum of the ship is OX. Okay, as the ship stirs to the left turn, so when it takes left turn means the active gyroscopic couple will change in the angular momentum vector from OX to OX dash. Okay, initial angular momentum of the ship is OX. When it takes left turn, so here change the direction OX to OX dash. Okay, so here the vector XX dash represents the active gyroscopic couple. XX dash represents the active gyroscopic couple and its direction which is perpendicular to the OX. Okay, so that is the left turn when the novel ship takes left turn. Next, right turn. So when it takes right turn, OX is the initial angular momentum. Next, when it takes new position OX dash, XX dash is the resultant. Okay, so that is the different positions when it takes left turn and right turn. So here when it takes left turn, so the effect of reactive gyroscopic couple and active gyroscopic couple we will see here. Okay, so here we will see when the ship steers the right under similar conditions. So already it is discussed in aeroplanes also, so same here also. So when the aeroplane takes left turn, what is the active gyroscopic couple takes place in there, same here also novel ship takes place. Okay, so here we will see when the ship steers to the right under similar conditions as discussed, the effect of reactive gyroscopic couple as shown in 14 bigger B to raise the stern and lower the bow. Okay, so stern means rear end of the aeroplane and bow means front end of the aeroplane. Okay, next when the rotor rotates in clockwise direction when viewed from stern, the ship steering to the left, then the effect of reactive gyroscopic couple will be lower the bow and raise the stern. So here what is the case? So when it takes left turn, so when it takes left turn and rotates in clockwise anti-clockwise direction, so that means here the resultant is lower the bow and raise the stern. Next case, when the ship steering to the right under similar conditions as discussed note 2 above, then there is a reactive gyroscopic couple will be to raise the bow and lower the stern. Okay, next, when the rotor rotates in clockwise direction when viewed from the bow or forend of the ship is steering to the left, then the effect of reactive gyroscopic couple will be raise the stern and lower the bow. Okay, it is already we have discussed in aeroplane, same here also repeated, that's why I will explain, that's why I will not explain here. When the ship is steering to the right under similar condition discussed note 4 above, then the effect of reactive gyroscopic couple will be to raise the bow and lower the stern. So these are the different cases we have already completed in aeroplanes, here also same. Okay, next, So here this is the effect of the gyroscopic couple on a novel ship during pitching. So first of all, what is pitching? Pitching is the movement of a complete ship up and down in a vertical plane. So generally pitching means movement of the ship up and down. Okay, so up and down in a vertical plane. Vertical plane means we have transverse axis. Okay, so pitching means it is the movement of a complete ship up and down in a vertical plane. So vertical plane means we have transverse axis. Okay, so this is the vertical plane, so that is the transverse axis. So here pitching is nothing but up and down motions of a vertical plane. Okay, in this case transverse axis is the axis of spin. So here transverse axis, this is the transverse axis. So here this is the axis of precision and longitudinal axis is the axis of spin. So here always longitudinal axis and that means axis of precision and axis of spin is perpendicular to each other. So then only we have gyroscopic effect, otherwise there is no gyroscopic effect. We have to remember this. Okay, in this case transverse axis is the axis of spin precision. So this is axis of precision. The pitching of the ship assumed to take place with a simple harmonic motion. Okay, simple harmonic motion. The motion of the axis of spin about the transverse axis is, we have to consider here simple harmonic motion. Okay, so here theta is the angle and simple harmonic motion means we have to consider this pi. Okay, here also we have three cases when the pitch takes upward direction and downward direction. So when the pitch takes upward direction means, so here initially angular momentum is Ox, so upward direction means Ox is changed to Ox dash, and downward motion also Ox changed to Ox dash. Okay, so there we have to left turn, right turn. Here pitching means upward movement and downward movement. Okay, next here angular displacement of the axis of spin from mean position after a time t seconds. Okay, so here the formula is theta equal to 5 sin omega 1 into t. So that is the formula for angular displacement of the axis of spin from mean position after a time t seconds. So formula theta equal to 5 sin omega 1 into theta. So here phi is nothing but amplitude of swinging, that is maximum angle turned from the mean position in radius. Okay, so phi is amplitude of spinning, that is maximum angle turned from the mean position in radius. Omega 1 is angular velocity of simple harmonic motion. So generally omega means angular velocity. Formula of angular velocity is 2 pi n by 60. So here we consider 2 pi by time period of simple harmonic motion in seconds. So that's why 2 pi by Tp radians per second. Next, angular velocity of precision. So generally precisional angular velocity omega p. So in aeroplanes precisional angular velocity omega p equal to v by r. We consider in aeroplanes precision angular velocity omega p equal to v by r. But here we will take omega p equal to d theta by dt. So initially we will take initial topic gyroscopic couple, I think. So here this omega equal to, we will take d theta by dt. So here we will take same omega p equal to d theta by dt. So here d by dt, the d already we know that theta equal to pi into omega 1 into t. Okay, so first here angular velocity of precision omega p equal to d theta by dt. So this formula already we had find out gyroscopic couple in I think second topic. So d theta by dt. So already we know that theta equal to 5 sin omega 1 into t. So substitute here d by dt of pi into sin omega 1 into t, that equal to, here we have to differentiate sin omega t with respect to t. So phi is constant value, sin omega 1 into t with respect to t తో చేస్తున్నాం కాబట్టి differentiate with respect to t, sin t కి cos t. Okay, so phi is constant value, sin omega 1 into t, sin omega 1 into t differentiation cos omega 1 into t. Again we have to differentiate here omega 1 into t. So t with respect to t కాబట్టి సో t ఈక్వల్ టు 1 ఒమేగా 1 ఉంటుంది. సో 5 ఇంటూ ఒమేగా 1 ఇంటూ కాస్ ఒమేగా 1 ఇంటూ t. ఓకే, సో హియర్ వీ హ్యావ్ టు differentiate 5 sin omega 1 into t with respect to t. So sin t differentiation cos t. So okay, 5 into cos omega 1 into t. Again we have to differentiate t. So t equal to 1 and omega 1. Finally 5 omega 1 into cos omega 1 into t. So that is omega p. Okay, the angular velocity of precision will be if cos omega 1 into t equal to 1. Angular velocity of precision will be maximum when if cos omega 1 into t equal to 1. So okay, here we have to substitute cos omega 1 in t equal to 1. So then only we get maximum precisional velocity. So here maximum angular velocity of precision omega p max equal to omega 5 into omega 1. So here omega 1 means cos, already cos omega 1 t equal to 1, we have to substitute 1 here. So finally we will get omega p max equal to 5 into omega 1. So that equal to 5 into omega 1. So here omega 1, we know that omega 1 equal to 2 pi by tp. So substitute here omega 1 equal to 2 pi by tp. Okay, so here I equal to moment of inertia and omega p equal to angular velocity. So finally maximum gyroscopic couple c equal to I into omega p. Okay, general topic, gyroscopic couple c equal to I into omega p. I means moment of inertia, omega means angular velocity 2 pi n by 60, and omega p equal to we consider v by r in aeroplanes, but here we consider omega p maximum. Omega p maximum equal to 5 into 2 pi by tp. So that is the difference between effect of gyroscopic couple in aeroplane and novel ship. Okay, so here we have to change the omega p only. There we used in aeroplanes omega p, but here we used omega p into omega p maximum. Generally omega p equal to v by r, but here we will take omega p max equal to 5 into 2 pi by tp. Okay, next. So this is when pitching is upward, the effect of the reactive gyroscopic couple as shown in figure B, okay, will try to move the ship towards starboard. On the other hand, if the pitching downward, the effect of the reactive gyroscopic couple shown in figure C is to turn the ship towards the port side. Okay, so when the ship takes upward motion and downward motion, that is called pitching. So when the ship takes upward motion, so that means it moves, it will try to move towards the starboard. So starboard means rear side. Okay, when it takes downward motion, so the ship will try to turn towards port side. Okay, so that is the difference between upward motion and downward motion. Next, the effect of the gyroscopic couple is always given on specific position of the axis of spin, that is whether it is pitching downwards or upwards. Okay, so here the gyroscopic effect is depends on upward motion and downward motion when considered in pitching. For example, when considered steering, it takes left turn or right turn. Pitching, upward motion or downward motion. The pitching of the ship produces forces on the bearings which act horizontally and perpendicular to the motion of the ship. Forces perpendicular act అవుతూ ఉంటాయి. The maximum gyroscopic couple tends to shear the holding down bolts. So next, the angular acceleration during pitching. So generally angular acceleration alpha equal to d square theta by dt square. So already we know that theta equal to 5 into sin omega 1 into t. So substitute here 5 into sin So already here we have square 5 into omega 1 square into sin omega 1 t. So here we have to differentiate this 2 times with respect to t. So first we have to differentiate sin theta equal to cos theta. Again cos differentiate cheste cos theta equal to minus sin theta. Okay, so here we have to differentiate this. So theta omega 1 square sin omega 1 into t. So that means cos square cos theta. So again we have to differentiate minus sin theta. Okay, so the angular acceleration maximum if sin omega 1 into t equal to 1. So all this is 1. Finally we will get alpha equal to omega 1 square. Okay, so that is the maximum position. Okay. Next, effect of gyroscopic couple on a novel ship during pitching. So generally when consider pitching here during rolling, so already we know that when the axis of precision is always perpendicular to the axis of spin, then only we have a gyroscopic effect. When consider rolling, here the pitching and axis of spin, precision and axis of spin acting on parallel axis. So when it acts in parallel axis, there is no gyroscopic effect. Okay, so here we will see, we know that for the effect of gyroscopic couple to occur, the axis of precision should always perpendicular to the axis of spin. If however the axis of precision becomes parallel to the axis of spin, there will be no effect of the gyroscopic couple acting on the body of the ship. Okay, so generally axis of precision perpendicular to the axis of spin, then only we will get gyroscopic couple. Otherwise there is no gyroscopic couple acting on the bodies. So here you will see, in case of rolling of ship, the axis of precision, that means axis of precision means it is available on the longitudinal axis, is always parallel to the axis of spin for all positions. Hence there is no effect of the gyroscopic couple acting on the body of the ship. Okay, so why there is no gyroscopic effect on rolling in ships means, here the axis of spin is parallel to the axis of precision. That's why there is no gyroscopic effect on novel ship during rolling. Okay, so when consider ship, we will conclude these three once again. So first, when consider ships, we have gyroscopic couple effect in three cases. First one is steering, second one is pitching, and third one is the rolling. So first one, steering, means when the ship takes complete curved path. So that means when it takes left turn or right turn. Okay, so when it takes left turn, there is one type of gyroscopic effect we will find. When takes right turn, another type of gyroscopic effect we will find there. Next, pitching means when the ship moves top to bottom. Okay, so upward motion, downward motion, then we have to front end is down or rear end is down, like that. Next one is rolling. So when consider pitching and steering, transverse axis of precision, axis of spin perpendicular to each other. Okay, that's why there is a gyroscopic effect in both cases. But when consider rolling, here axis of precision and axis of spin parallel to each other. That's why there is no gyroscopic effect in rolling. Okay, so next we have to do the problems. Take one problem here. The turbine rotor of a ship has mass of 8 tons and a radius of gyration of 0.6 meters. It rotates at 1800 rpm clockwise when looking from the stern. So stern is nothing but rear end of the aeroplane. Front end is called bow and rear end of the aeroplane stern. Determine the gyroscopic couple if the ship travels at 100 kilometers per hour and steer to the left a curve of 75 meters radius. First we have to note down the given data. So for doing any problem, first we have to see what is given data available in that problem and what are the terms we have to find out. Okay, for example, here we have to find out, determine the gyroscopic couple. So what is the formula of gyroscopic couple in ships? So ships means here we have gyroscopic couple of formula of the gyroscopic couple in ships C equal to I into omega p. Okay, so we have to find out C value. First we know I value and omega value and omega p value, then only we have to find out C value. Okay, so ప్రాబ్లంలో మనకి ఏమి ఇచ్చాడు, మనం ఏం ఫైండ్ అవుట్ చేయాలి. ఫర్ ఎగ్జాంపుల్ గైరోస్కోపిక్ కపుల్ ఫైండ్ అవుట్ చేయాలి. ఫార్ములా ఏంది గైరోస్కోపిక్ కపుల్కి ఇన్ షిప్స్లో? సో మనకి గైరోస్కోపిక్ కపుల్కి ఫార్ములా షిప్స్లో ఏంది అంటే C ఈక్వల్ టు I ఇంటూ ఒమేగా పి. సో మనకి గివెన్ డేటాలో I వాల్యూ ఎలా ఫైండ్ అవుట్ చేయాలి, దేన్ని బేస్ చేసుకొని మనం I ఫైండ్ అవుట్ చేయాలంటే గివెన్ డేటాలో మనకి ఇచ్చిన వాల్యూస్ ఓకేనా లేదా అలా మీరు కొంచెం థింక్ చేసి ప్రాబ్లమ్స్ సాల్వ్ చేసుకోవాలి. ఓకే, సో హియర్ formula for gyroscopic couple in ships C equal to I into omega p. So first we have to find out I value, moment of inertia. So formula for moment of inertia I equal to mk square. So m means here mass మనకు ప్రాబ్లంలో ఇచ్చాడా లేదా చూసుకోండి. mass of 8 tons. So here mass is given in terms of tons converted into kgs. So 1 ton equal to 1000 kgs. Okay, you have to remember these units. Always you have to mention each and every calculation, you should mention the units. Okay, in exam point of view also. So that's why first we have to see the యూనిట్స్. సో కేజెస్లో ఉన్నాయా, టన్స్లో ఉన్నాయా, మిల్లీమీటర్స్లో ఇచ్చారా, మీటర్స్లో ఇచ్చారా. ఫర్ ఎగ్జాంపుల్ మాస్ కేజెస్లో ఇచ్చాడు, లెంత్ అలాంటివి మిల్లీమీటర్స్లో ఇస్తే దాన్ని మీటర్లో కన్వర్ట్ చేసుకోవాలి. సో ఇలాంటి యూనిట్స్ కొంచెం ఇంపార్టెంట్ అన్నమా ప్రాబ్లమ్స్లో. సో చూడండి, సో మాస్ ఈక్వల్ టు 8 టన్స్. సో 1 టన్ ఈక్వల్ టు 1000 కేజెస్. సో 8 ఇంటూ 1000. సో మాస్ ఈక్వల్ టు 8000 కేజెస్ వస్తుంది. నెక్స్ట్ మనం ఏం ఫైండ్ అవుట్ చేయాలి, మూమెంట్ ఆఫ్ ఇనర్షియా I ఈక్వల్ టు mk స్క్వేర్. కే ఆల్రెడీ వాడు మనకు ప్రాబ్లంలో ఇచ్చుంటాడు. రేడియస్ ఆఫ్ గైరేషన్ K ఈక్వల్ టు 0.6 మీటర్స్. సో ఫస్ట్ మీరు ప్రాబ్లం చదవంగానే కింద గివెన్ డేటా రాయండి, షార్ట్కట్లో కాదు. గివెన్ డేటా మాస్ ఆఫ్ ది రోటార్ m ఈక్వల్ టు 8 టన్స్, రేడియస్ ఆఫ్ గైరేషన్ K ఈక్వల్ టు స్పీడ్, రొటేషనల్ స్పీడ్ n ఈక్వల్ టు అలా రాసుకోండి. ఓకే, సో I ఈక్వల్ టు mk స్క్వేర్, m ఈక్వల్ టు 8000, K ఎంత ఇచ్చారు 0.6 మీటర్స్. సో K హోల్ స్క్వేర్ కాబట్టి 8000 ఇంటూ 0.6 హోల్ స్క్వేర్. సో మీకు అప్పుడు వాల్యూ ఎంత వస్తుందో చూసుకోండి. సో K I ఈక్వల్ టు 2880 kg per meter square వస్తుంది. నెక్స్ట్ ఒమేగా పి, యాంగులర్ వెలాసిటీ ఆఫ్ ప్రెసిషన్. ఒమేగా పి ఈక్వల్ టు V/R. ఓకే, సో V/R. మా ఒమేగా పి మ్యాక్స్ ఎప్పుడంటే పిచ్చింగ్లో, మనం స్టీరింగ్లో ఒమేగా పీనే కన్సిడర్ చేస్తాం. ఒమేగా పి ఈక్వల్ టు V/R. సో V అంటే ఏంది ఇక్కడ, V అంటే వెలాసిటీనా చూడండి. సో హియర్ ది కర్వ్ ది షిప్ ట్రావెల్స్ ఎట్ 100 కిలోమీటర్ పర్ అవర్. సో కిలోమీటర్ పర్ అవర్ని కిలోమీటర్ పర్ సెకండ్స్లోకి మీటర్ పర్ సెకండ్స్లో కన్వర్ట్ చేసుకోండి. ఓకే, సో 1 కిలోమీటర్ ఈక్వల్ టు 1000 మీటర్స్ 1000 మీటర్స్ అంటే 100 ఇంటూ 1000 బై అవర్స్ని సెకండ్స్లో కన్వర్ట్ చేయండి. 1 అవర్ ఈక్వల్ టు 3600 సెకండ్స్ కన్వర్ట్ చేసుకోండి. మనకి వాడు ప్రాబ్లంలో V వచ్చేసి వెలాసిటీ 100 కిలోమీటర్ పర్ అవర్ ఇచ్చాడు, దాన్ని మీటర్స్ పర్ సెకండ్లో కన్వర్ట్ చేస్తున్నాం. సో 1 కిలోమీటర్ ఈక్వల్ టు 1000 మీటర్స్, 1 అవర్ ఈక్వల్ టు 3600 సెకండ్స్. సో 100 ఇంటూ 1000 బై 3600 వేయండి. అప్పుడు మీకు ఆన్సరు 27.8 మీటర్స్ పర్ సెకండ్ వస్తుంది. ఓకే, బై ఆర్ వాల్యూ 75 మీటర్స్ ఇచ్చాడు. సో 75 వేయండి. ఫైనల్లీ వీ విల్ గెట్ ఒమేగా పి ఈక్వల్ టు 0.37 రేడియన్స్ పర్ సెకండ్. నెక్స్ట్ వీ నో దట్ గైరోస్కోపిక్ కపుల్ C ఈక్వల్ టు I ఇంటూ ఒమేగా పి. మనం I ఫైండ్ అవుట్ చేసాం, ఒమేగా పి కూడా ఫైండ్ అవుట్ చేసాం. ఒమేగా మనకు ఆల్రెడీ స్పీడ్ ఇచ్చాడు, n ఈక్వల్ టు 1800 RPM. దెన్ ఫైండ్ అవుట్ ఒమేగా ఈక్వల్ టు 2πn/60. సో 2π ఇంటూ 1800/60 వేస్తే ఒమేగా వాల్యూ 188.5 రేడియన్స్ పర్ సెకండ్ వస్తుంది. అవన్నీ సబ్స్టిట్యూట్ చేసుకుంటే సి ఈక్వల్ టు ఐ ఇంటూ ఒమేగా పి. ఒమేగా వాల్యూ 2880 అండ్ ఒమేగా 188.5 and omega p 0.37. Finally we will get 200,866 Newton per meter. దీన్ని కిలో న్యూటన్ మీటర్లో కన్వర్ట్ చేస్తే 200.866 కిలో న్యూటన్ పర్ మీటర్. సో న్యూటన్ పర్ మీటర్ని కిలో న్యూటన్లోకి మార్చాలంటే by 1000 వేస్తాం. ఓకే, సో దిస్ ఈజ్ ది గైరోస్కోపిక్ కపుల్ ఆఫ్ ది షిప్. సో నెక్స్ట్ what we have to find out, determine gyroscopic couple of the ship and travels. Okay, next, when looking from stern, so effective, when the rotor rotates in clockwise direction when looking for stern and the ship steers to the left, the effect of the reactive gyroscopic couple is the raise the bow and lower the stern. So that is effect of the షిప్. ఓకే, నెక్స్ట్ ఈ ప్రాబ్లం నెక్స్ట్ స్లైడ్లో రిపీట్ చేస్తున్నాను, చూద్దాం ఇక్కడ. సో హియర్ నెక్స్ట్ వన్ ప్రాబ్లం. సో ది హెవీ టర్బైన్ రోటార్ ఆఫ్ ఏ సీ వెజల్ rotates at 1500 rpm clockwise looking from the stern, its mass being 750 kg. Vessel pitches with angular velocity of 1 radians per second. Determine gyroscopic couple transmitted to the hull when the bow is rising. If the radius of gyration for the rotor is 250 mm, also show in what direction the couple acts on the hull. Okay, so first note down the given data. So here we have to given n equal to 1500 rpm. So find out omega equal to 2 pi n by 60. So 2 into 1500 by 60. Finally we will get omega equal to 157.1 radian per second and given mass 750 kg, m equal to 750 kg, p equal to, so angular velocity of p, so 1 radian per second, and radius of gyration k equal to 250 mm. So here కేజెస్లో ఉంది మాస్, millimeters converted into meters, so 0.25 meters. Finally we know that mass moment of inertia. So here we have to remember this. So here the problem is depends on pitching case. So pitching case means what is the formula here we will use? C equal to I into omega p. That means p max we have to add here. So చూడండి, I equal to mk square, m 750, k 0.25. సో ఫైండ్ అవుట్ చేసుకుంటే 46.875 kg per meter square వస్తుంది. నెక్స్ట్ గైరోస్కోపిక్ కపుల్ ట్రాన్స్మిటెడ్ టు ది హల్, దట్ ఈస్ బాడీ ఆఫ్ ది సీ వెసల్. ఓకే, నెక్స్ట్ హియర్ ది ఫార్ములా ఈజ్ సమ్ మిస్టేక్, c equal to I into omega p. Okay, so here it is not copied, so I did one mistake here. So the formula of c equal to I into omega p. So already I మనం ఫైండ్ అవుట్ చేస్తున్నాం, 46.875 into omega p 157.1 into precision, already it is given in problem 1. So substitute here 7364 Newton meter, so converted into kilonewton, so that's why 7.364 kilonewton per meter. So next, effect of gyroscopic couple. When the bow is rising, that is when pitching is upward, the reactive gyroscopic couple acts in the clockwise direction which moves the sea level towards the starboard. Okay, so the rise అయినప్పుడు, okay, when the bow is rising, the pitch is also moves upward, so then the reactive gyroscopic couple is towards the starboard. Next problem, note down. So here the turbine rotor of a ship has a mass of 3500 kg